All right, last little point of review. This is nothing new, and you experienced this on your homework and in our discussions, not yesterday, but the day before, and then before break. There's one more thing that's important enough for me to review again. I'm going to put it in words. So you don't really need to write it down, but you need to gaze upon it again because it's so important. And I think it's already in your book. So if it's not in your comp book, you may write it down. And that is, trash in this chalk today. All right. The summation is n goes from 1 to infinity of a sub n, which is just a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, blah, blah, blah. Actually converges if the sequence of partial sums, and that's what we just did on 2 examples, but I'm just putting it in words, converges. So, converges if the sequence of partial sums converges. So if we take that and we find that this converges to some limit L, then we actually know this sum is L, which is quite astounding that an infinite sum can have an answer, and it's a normal number. But it's true, so. All right. Like I said, all of that is review. Can I get rid of these sections?
Yes.
All right, we're into telescoping series. I wrote down a statement in your comp book, so someone who writes fast, who's already done writing that side, if you're writing it, I think it's already in your book, should be. Read to me the last statement. It was a theory about a telescoping telescoping series that we had. Do you have that, Erin?
Was it this part?
It had words, yeah.
If a sub n converges, so does the whole series. If a sub n converges, the sum of a sub 1 minus the limit as that approaches infinity, a sub n plus 1.
Plus 1?
I don't know what that means.
Okay, all right. Do you have some statement like that as well? What's yours saying, Gianni?
Mine says if a sub n converges, the series converges, and if a sub n converges, then the sum is equal to a sub 1 minus the limit as n approaches infinity of a to the n plus
Okay.
a sub n plus 1.
Okay, it was plus. All right, we're going to make some sense out of that. And the way we're going to do it is we're going to actually do that. Did you watch that video?
Yes.
Okay, so you've heard that. And we're going to do 2 of these, and I'm going to assign 5, but the 2 will make sense of those words. So, as a math teacher, you never know whether to give the words first and then the problem, or vice versa. So, I kind of do a dance. I do it one way and then the other. All right. We've already seen this one. If you look back in your notes, you'll find it. So find it, before we introduced it as telescoping, we did it as a regular problem. And when we did that, we took a look at what it generated, and here's what it generated: 1/2 plus 1/6 plus 1/12. Do you find that somewhere? Do you have that in your book? All right. So when we did that, we did the partial sums, and they generated 1/2, 2/3, 3/4, and this is one of the rare occasions where we can come up with the generator of this sequence of partial sums. And you can see the pattern. The top is 1, 2, 3, 4, so top is n, and the bottom was 1 above that, so n plus 1. So, as this says, this series will converge if the sequence of partial sums, which is dictated by this in this example, if that approaches a number or not. So when we did that, I think we used L'Hopital, and we got 1/1. So it does converge, and this whole sum, when I add all these up, it equals 1, which is kind of amazing that an infinite number of sums adds up to a finite number. But so it does. So, all right, let us now, we decided the problem, the boogaboo, if you will have a boogaboo, it's right there, because not always can we come up with that. And I told you before, it's troublesome. So this one, we could see it quite clearly, but a lot of times, especially on these kind, you can't find it. So I'm going to look at this problem a different way and notice that it telescopes. So we had started that as well. And how did we do that? I remember. All right, let me help me build that up again. So Morgan, either finding it in your book, instead of doing this minus this and adding it to get that, we kept it in its separate terms. So when we put a 1 here, I can see we got 1 minus a half, then what?
1/2 minus 1/3.
And then what?
1/3 minus 1/4.
That'll do. Thank you. All right. So then we noticed that we had a situation where this crossed out that, and this crossed out that, and this crossed out that. And this is going to go on to the very end of time, where we're going to hit this expression again, 1 over n minus 1 over n plus 1, down here at the very end, where we're going to stop. So, this is then everything's going to cross out. So we have, this will cross this out, this will cross this out. There'll be something in front or behind that that'll cross this out. There'll be something behind this that'll cross this out. But the first term and the last term are going to remain. So nothing's going to cross those out because we're stopping there. So as we take this telescope, remember it folds into one another. We have a beginning and an end. So when we look at that then, the sum is 1 minus 1 over n plus 1. So we're going to, on these telescoping ones, we take the first term and the last. The first, where did it come from? By putting a 1 into this and generating a 1. The last, where did it come from? Right here, in the definition of the problem. Alright, so now we take the limit of that as n approaches infinity. Because we're not really stopping at any n, we're going on forever. And what limit does that eke out for us, Morgan?
1 minus 1 over, so 1.
Right, 1. And so that's how we got it the other way. Now you say, well, I might rather do it this way than this way. Well, that's fine and hunky-dory, but can you come up with that? And a lot of our problems, it's a lot harder than you think. So if we can't come up with it, this is another way that we can do it. So, going back to those words again. So Gianni, would you read those words again a little slower? The words that described that theory behind this.
If a sub n converges.
All right, here, where's a sub n in this thing? Can you find it anywhere? A sub n is right here. All right, it converges. Go ahead.
Then the series converges.
All right, so we're good with that. Keep going. To what?
It converges to the sum of a sub 1.
A sub 1 is this number, so there it is. Go ahead.
Minus the limit as n approaches infinity of a sub n plus 1.
All right, so here is my a sub n plus 1. The only thing that those words are saying is you're taking the first term and the last. That's really all it's saying. You're taking the limit as it goes to infinity. So there we go, like that. I think within the words they're actually saying the 1 is out here, but a sub 1, but it doesn't matter whether it's in behind the limit sign or not. All right, so let's pick up from there. We have all that groundwork behind us. Have we finished with this side?
Yeah.
All right, I'll just do a geomet. That was the one. Did we just finish that one? I don't think we did. We finish that one? Telescoping.
Yes.
Yeah.
We did on
Yeah.
on Thursday, Wednesday. Okay, so this is exactly where we were. All right, take this one and see what you can do
No
with
video.
it. We're still on telescoping series, and,
Is it 10 minutes, pal?
okay.